Okay, so in today's video we're going to have a look at speed, distance, time, and we're going to have a look at specific questions where journeys are being mixed together. So where we've got these sorts of problems where there's one part of a journey, a second part of a journey, and we're trying to find out something to do with the overall journey or vice versa in reverse. So we're going to have a look at some of these questions. Some of the wording kind of puts people off these questions, but I'm going to show you a nice easy way of actually going about solving them. And you might recognise this method from something I've used in one of my previous videos as well. So grab a piece of paper, grab a pen, make some notes, and we're going to kickstart with this question. Now for the majority of these questions I am going to be using a calculator method, although there are some types of speed, distance, time questions where we may not need a calculator, and some of these we might not actually need one, so I'll have a look at thinking about that throughout the video, whether we actually need a calculator or not. But for this particular question, let's start having a look. So it says the distance from, I'm going to refer to these places as just their starting letters, from C to D is 45 miles. There we go, so that's the first part of this journey. Then it says from D to E is 20 miles. It says Colin drives from C to D, and then he drives from D to E. Colin drives from C to D at an average speed of 30, and then he drives from D to E at an average speed of 40. And we're looking at miles per hour in this question. Work out Colin's average speed for the whole journey from C to E. Now what I want to do is I want to organise all this information. And if you've seen my video on density, looking at mixture problems, I'm going to organise this in a very similar way. Now what I did in that question is I drew a two-way table. I'm going to do the same process for this one. Now on the left of this two-way table, rather than mass density volume like we had in that one, we're going to have speed, distance and time, and we need to know our speed, distance, time formula. Now speed is distance over time, and for those of you that like formula triangles, it's nice and quick for this question just to use a formula triangle, and we have speed, distance, time. Obviously not forgetting though that you do need to be able to rearrange that formula, obviously for your algebraic sort of methods with rearranging formulas as well. But speed is distance over time, and then obviously distance is speed times time, and time is distance over speed. So I talked about it in that video, but obviously when you use a formula triangle, all you have to do is cross off the one you're looking for. So speed, if we cross that out, and you get there distance divided by time. And likewise with the top, look, you cross off distance, and you have speed times time. So it's just a little quick reminder on how to use the formula triangle there. But now let's have a look at constructing the top of this table. So we've got from C to D, which is the first part of our journey. I'm just going to label that as C to D. Then we have D to E. There we go. And we also have our total journey. So let's just call that the total. Again, you can label these whatever you like. Okay, it's purely a way of categorizing and tidying up this information. So there's no set method for actually doing this. Now, if I just obviously draw in all my grids now, and let's just start filling some of these things in. Now it says work out Colin's average speed for the whole journey. So we're looking for this box here, the average speed for the whole journey. So that's our little goal there to get to that box. Now let's fill in what we've actually got. So we have from C to D was 45 miles. That's a distance, so 45. We've got from D to E is 20 miles. Again, that's a distance. And then later on we've got the speed from C to D is 30, so that'll be 30, and the speed from D to E is 40, so we can fill that in as well. Now we've not been given any more information, but there is one box that we can work out, and that is obviously the total distance there. If the distance on the first part is 45, the second part is 20, the overall distance is 65. Obviously just remembering that speeds cannot be blended together. If I go 30 part of the way, 40 another part of the way, that doesn't combine to make 70. I haven't driven 70 miles an hour at any point, so we don't just add those together, but we can do with distances and we can do with times, thinking about the logic of an actual journey here. Okay, so the average speed is going to be somewhere in between 30 and 40. And unfortunately, because the distances are not equal here, we can't think about doing some sort of average there because it's in a different proportion for each part of this journey. But what we can do is work out these times now, so I can go about actually working these times out. So think into our formula triangle. If I cross off the T up the top there, it's distance divided by speed. So I can go about working that out then. So distance there is 45, and we're going to divide that by the speed, which is 30, and 45 divided by 30, and I'm just going to do this one on the calculator, gets us 1.5 straight away on the calculator. So 1.5, and it's miles per hour, so that's 1.5 hours. Now the next one to the right of that, we've got a distance of 20 and a speed of 40, so I can do 20 divided by 40, and that gives me a half, or 0.5. There we go. And that can then be added together, look, because if the first part of our journey was 1.5 hours, the next one was 0.5, that's a total of 2 hours for the whole journey there. Now finishing that off, speed equals distance divided by time, so 65 divided by 2 there to finish that off. 65 divided by 2 is 32.5. And obviously this question is in miles per hour, so we just put miles per hour. There we go, and that finishes that question off. So obviously just looking at categorising all these pieces, having a look at what journeys you have, and just writing down whether you have a speed, a distance or a time for each one of those journeys, and then just going about filling in those missing pieces. All you need to remember is that obviously distances can be added together, times can be added together, but the speeds cannot, and we are going to have to figure out the distance and the time in that final journey there to actually go about working out that speed. But there we go, there is one of these types of questions. Let's have a look at another one before you have a go. Okay, so this question says Sean drives from Manchester to Gretna Green, so M to G. He drives at an average speed of 50 miles an hour for the first 3 hours, so for the first part of the journey. Then he has 150 miles to drive to get to the end of his journey there to Gretna Green. So Sean drives those 150 miles at an average speed of 30 miles per hour. Sean says my average speed from M to G, so the whole journey, was 40 miles an hour. Is Sean right? And you must show how you get your answer. So it's a very similar process in terms of the last question, except we're actually just comparing it to his statement in this question, so we will have a final conclusion to make. So if we have a look at this, let's have a look. Now it doesn't stop in between different places this time, so let's just say the first part of the journey, the second part of the journey, and the total. And let's have a look at figuring this out. And then we've got a speed, a distance and a time to have a look at for each part of that journey. There we go, speed, distance, time. And there's our table. So let's have a look. That first part of the journey, it says he drives at an average speed of 50 and the time is 3 hours. The next part, he then drives 150. Hold on. Let's make sure that goes in the right place. He then drives 150 miles, so that's a distance. Almost put that in the speed there. And that is at an average speed of 30. There we go. So there is our information. So unfortunately at the moment we can't add together any distances and we can't add together any times because we don't actually know what they are just yet. But we can figure them out and we can go about having a look at those. So let's have a look to start with. So let's write down our formula. Speed is distance divided by time. There we go. And let's have a look at this one to start with. So we can work out this distance here. So distance is speed times time. So 3 times 50. So 3 times 50 gives us a distance of 150. There we go. And now we can add those two distances together. We've got a distance of 300. And then we can work out the time for that second part of the journey there. So time is distance divided by speed. So 150 divided by 30 gives us a time of 5. So there's 5 hours there. Right, there we go. So if we add those two times together, that gives us a total of 8 hours. And then we can actually work out his overall speed. Speed there is, remember, distance divided by time. So for this final box here, we can do 300 divided by 8. And 300 divided by 8, let's have a look. 300 divided by 8 is 37.5. There we go. So 37.5 miles per hour. There we go, and there's our final answer. So it says, obviously, he said my average speed was 40 miles an hour. Is Sean right? So we would say no. His speed is 37.5 miles per hour. There we go, so there is another type of question there. Obviously the same process, but obviously just concluding that with a final statement there. So we would say no, his speed is 37.5 miles per hour and not 40 miles per hour. Okay, there we go. So here's a couple of here's one question for you to have a go at before we have a look at something ever so slightly different. Okay, so here's your question to have a go at. So pause the video there, have a go, and we'll go over the answers in a sec. Okay, so drawing our two-way table for this question then. We've got A to B, and again you might have labelled this differently. Then we've got B to C, and then we've got our total. And again we're looking for a speed, a distance and a time for all these parts of each journey. There we go. So let's actually put some of these numbers in. We've got a distance of 60 miles for the first one, and we've got a distance of 35 miles for the second journey there. And that's a total of 95 miles. There we go, so we can put 95 in as well. It says Amy drives from Ashby to Burley at an average speed of 30, so we'll put a speed of 30 in, and we've got an average speed of 70 for that second part of the journey. And we want to work out the average speed for the whole journey. So we're trying to work out this box here again. So if we start putting these ones down the bottom, look, we've got speed is distance divided by time. And if we're working out our time, it's distance divided by speed. So 60 divided by 30 for that column there gives us 2 hours. And for this one over here, we've got distance is 35, and we're going to divide that by 70, and that gives us 0.5. There we go. So in total, we have 2.5 hours. There we go. And our total journey there is 95 miles. So if we want to do that, we're going to do distance. There we go, divided by our time. So speed is distance over time. So we're going to do the distance of 95 divided by the time, which is 2.5. And we have 95 divided by 2.5. And we get 38. There we go, miles per hour. There we go, and there is our final answer for that question. Okay, so again, just categorising all those bits of information, filling in any missing pieces, and just remembering for that overall journey there, we need the overall distance and we need the overall time in order to work out our overall speed. Let's have a look at something that's where, you know, something slightly different happens, okay? So in this question here, it says Ollie drove 56 kilometres from Liverpool to Manchester, and then he drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour, and he took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive. So the first thing is we've got all this information, so we can start putting that into our table. We've got this one here, a speed, and we've got this time here, which is in minutes, and that's the first time minutes has appeared on one of these questions. But let's have a look at what happens when we just start putting these in. Now, if I go for this journey, let's have a look. We've got L to M, Liverpool to Manchester. Then we've got Manchester to Sheffield. And we've got the overall or the total journey. There we go. And again, we're looking for a speed, a distance, and a time. And again, I'm going to put down my speed equals distance over time formula triangle. There we go. So if I start to fill in some of these, and let's just put all these grids in to start with, let's see what we've actually got. So we've got 56 kilometres for the first bit, that's a distance, and we've got 61 kilometres for the next one, and we can add those together. 56 plus 61 is 117 for our total distance. So we've got an average speed from L to M of 70, and we've got a time of 75 minutes. I'm going to put that there, 75 minutes. Now, when it comes to this question here, we'll have a look at what we're going to do with that 75 minutes, because that's our little change in this particular question. So we'll come back to that. But to start with, we can actually work out this time here, can't we? So we've got time is distance divided by speed. So we can do 56 divided by 70. And 56 divided by 70 gives me 0.8. Right, there we go. So we've got 0.8 and 75. Now obviously we can add together distances and we can add together times as well, but doing 0.8 plus 75 seems a bit bizarre. 75.8 is not going to be correct there because the 0.8 is in hours and the 75 is in minutes. So before I add these together, I want to make sure that they're in the same units. Now in this particular question, we're obviously working out a speed, and our speed up here in the question, look, is in kilometres per hour. So we want to have that 75 minutes in hours. So for the first thing that we need to make sure we do is make sure that we get an amount of hours there. So you might know what that is in terms of hours, but if you don't, you can just divide it by 60. So 75 divided by 60 is 1. Let's just type it in just to make sure we get this on the calculator. There we go. We get 1.25, which makes sense because we've got 15 minutes additional on top of that 60, and 15 minutes is 1/4 of an hour. So that's going to be 1.25 hours there. There we are. And now we can actually go about working out that total time. Okay, we can add those two together now and we get 2.05. Okay, so 2.05 hours. So we're looking at this now. Actually, look, we don't even need to work out this speed box here. It doesn't ask for its speed between Manchester and Sheffield. We've now actually got all our pieces that we need to get our speed for these for this final total part of the journey. So actually, we didn't even need to work out one of those boxes. So we can just go straight ahead and work this one out here. So speed is distance over time. So we have 117 divided by 2.05. Let's see what we get. 2.05. And we get a pretty nasty number here. We get 57.07317. There we go, and there's a recurring decimal above the 0 and above the 7. Now it's more than likely that this type of question here would then say give it to the nearest kilometre per hour, or give it to the nearest decimal place, or something like that. But obviously just remembering in terms of an exam, if it doesn't say how to round the answer, you don't go about rounding it in any way at all. You would just write that full answer down there, and we would say that there in kilometres per hour. There we go. Quite an unlikely answer to appear in an exam if it didn't want you to round it, but there we go, it would tell us in an exam how to round that particular question. Right, let's have a look at one more. Okay, so this question says Harry travels from A to B at an average speed of 50, and then he travels from B to C at an average speed of 70. Harry takes a total of 5 hours to travel from A to C, and the distance from B to C is 210. Calculate Harry's average speed. Right, so let's have a look at this one then. So we've got A to B, and we've got B to C, and then we've got the total overall journey there. There we are. And thinking about what we've got a speed, distance and a time, and we'll see what happens in this question. So in this question here, let's have a look. We've got an average speed of 50 for the first one, an average speed of 70 for the next one, and then we've got a total time of 5 hours from A to C. So this time we've been given our total. Look, we've got 5 hours as our total, and we've got the distance from B to C, which is 210. There we go, so 210. Right, so let's have a look at how we can now go about working this one out then. So ultimately we are looking for the average speed for the total journey. So we're looking for this one here, but we're missing quite a lot of pieces. Now what we can do is we can start to work backwards. So if we have a look at this first section here, this second journey from B to C, from Brockley to Cantham, if we can go about working that out, we can get this time down below, and we can definitely do that. Speed is distance over time. So time down the bottom for this first little box that we can work out here is distance divided by speed. So 210 divided by the speed, which is 70, and that gives us 3 hours for that part of the journey. Now we can work backwards because we know that these two journeys have to add together to make 5. So the other part of the journey, if we do 5 take away 3, tells us that this first part of the journey must have been 2 hours. And now we've got that, we can work out the distance of that journey. Distance is speed times time. So this one here, speed is 50 and the time is 2, so that must have been 100 miles. There we go, and now we can get our total distance for that journey there. So we've got 100 plus 210, and that equals 310. And now we can just finish it off like a normal question. So it's not particularly any more difficult than the previous questions. It's just actually working backwards to go back to that first part of the journey so that we could get the overall distance for this total journey here. So now we can do our normal sum. We've got distance divided by time, so we've got 310 the total distance divided by the 5 hours, and 310 divided by 5 is 62 miles per hour. There we go. And also thinking about the logic here, that is in between 50 and 70, so our answer makes sense. And you should always be thinking about that. Does my answer make sense? Is it somewhere in the middle of the two? So there we go. That is another type of question there. And then here is one for you to have a go at. Okay, so here's your question. So pause the video there, have a go, and we'll go over the answer in a sec. Okay, so for this one here then, let's draw our table. We've got C to D, we've got D to E, and then we've got our total. There we go. And we're looking for a speed, a distance, and a time. And let's just draw our formula triangle in again. Speed, distance, time. There we go. And we'll make sure we keep using that throughout every question. So we have an average speed of 60 for the first part of the journey, and an average speed of 50 for the next one. Then it says we've got a total time of 6 hours, and it says the distance from D to E is 110. There we go, so 110. So a very, very similar setup to our last question that we actually looked at. Again, where we're going to have to work backwards to work out this average speed for the whole journey, which is what the question's looking for. So if we start working backwards then, we can work this one out to start with. So time is distance divided by speed. So we have 110 divided by 50, and 110 divided by 50 gives us 2.2. So we have 2.2 hours. So something is getting added to 2.2 that's going to give us our total of 6. So we can do 6, take away that 2.2, and that leaves us with 3.8 hours. And there we go for that first part of the journey. So now we can work out the distance. Distance is speed times time. So we've got 60 multiplied by the 3.8. And if we times that 3.8 by 60, we get 228 miles. So now we can add those two distances together, and that tells us we've got 338 miles in total for this particular journey. So now we can finish this off. We can answer our total speed there for the overall journey, and that is the total distance, which is 338, divided by the total time there, which is 6, and 338 divided by 6 gives us a speed of 56.3 recurring miles per hour. There we go. And that particular question again doesn't ask us how to round it, so I'll just leave that as 56.3 recurring miles per hour. Right, okay, so we've almost finished. We've got one more question to have a look at. This is going to be our final question. It's going to be something slightly different, slightly trickier, but that is going to be our last question, so let's have a look at that one now. Okay, so this question says, James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James, and Peter caught up with James when they both cycled 15 kilometres. James and Peter both cycled at constant speed to work out Peter's speed. Now this particular question here isn't necessarily a mixture of journeys, but we have got two people completing the same journey, and it's quite tricky to actually figure this one out. So we're going to have a look anyway and see what we can put in our table just to sort of categorise this and take some of the information away from the question. So if I have a look, I'm going to start drawing a table and start to think about when I might use a column. So we've got speed, distance and time, and we're going to have a look at, to start with, the overall journey which we can do there, because we've got James took 2.5 hours to cycle that 50-kilometre route. So overall we've got James, and that's his total journey to start with. Let's just have a look at working that out. So the James is total. We'll see what we need in a second if we need to extend this. So James took 2.5 hours, so his total time was 2.5, and it was 50 kilometres. There we go. So straight away we can work out his speed. So speed is distance over time, so 50 divided by 2.5, and let's just write down our formula again. Speed is distance over time. There we go. And 50 divided by 2.5 gives us an answer of 20. There we go. So his speed was 20 kilometres per hour. Then it says Peter started to cycle 5 minutes after James started to cycle, but caught up when they had cycled 15 kilometres. So we're not really concerned about the overall journey here. Now we're looking at these two little journeys that they've gone on that are both only 15 kilometres long, but they've done them in different times. It says James and Peter both cycled at constant speeds, work out Peter's speed. So if we have a look, we've got these two journeys to have a look at, both the same journey, but we've got James and we've got Peter. There we go, let's just categorise this. Now let's start filling in some of the information that we've got. So we've got, they both cycled 15 kilometres, that was their distance. There we go. We've already know James's speed because we've just worked it out. So James's speed is 20, and we know that Peter is going to start 5 minutes after James. So if we have a look at this, let's work out James's time. We can work that out down here now. So the time that James took to do these 15 kilometres, time is distance divided by speed, so 15 over 20. And 15 divided by 20 gives us 0.75. Okay, so 15 divided by 20, 0.75. There we go. So to actually get this last little bit now, look, if that's 0.75, it says that Peter started cycling 5 minutes after. We actually need to know what that is in minutes. So let's times that by 60, turn it back into minutes. And 0.75 times 60, well, it's 3/4 of an hour, so that's 45 minutes. Now this is a relatively difficult aspect of it, because if we have a look, Peter started 5 minutes after. Now that means that Peter caught up 5 minutes faster, or did the journey, did that 15 kilometres 5 minutes faster than James. So Peter didn't do it in 50 minutes, but he did it in 40 minutes, okay? So even though he started 5 minutes after, think about that logically, that means he did it 5 minutes quicker, okay? Because he actually started after James. So he did it in 40 minutes instead. So actually now, once you've got your head around that little bit of logic, Peter here, we can work out his speed. And speed is going to be distance divided by time. So that's going to be 15 divided by 40. And 15 divided by 40 gives us, let's have a look, hold on, distance divided by time, gives us a decimal. Now, if we get the decimal for this one, let's have a look. That doesn't look right compared to James's 20. So there's another aspect that we need to think about here, because obviously we want to compare their speeds, okay, in the same units. Now, James's speed is in, where is it gone? There it is, 20 kilometers per hour. So we definitely don't want to divide by an amount of minutes. And obviously we've got 40 minutes in there at the moment. So let's just rethink that sum, because we want to put 40 in terms of an amount of hours. So we're going to convert that to start with, and let's bring that up here. So that's going to be 40 minutes out of 60 minutes, and 40 divided by 60 gives us the decimal 2/3. So we get 0.6 recurring as his time. Okay, it's exactly 2/3 of an hour. Let's see if we can squeeze that in there. 0.6 recurring. So that's the decimal we want to use when we're working out his speed. So speed is distance over time. So instead we're going to do 15, and we're going to divide that by the 0.6 recurring. Okay, so 15 divided by that answer there, 0.6 recurring, gives us a final speed of 22.5 kilometers per hour. There we go. So obviously just using that hours amount. Now here's something else to be having to think about. I'm going to get rid of some of this, because this could potentially be a non-calculator question, and we're going to have a look at how we could have done this without a calculator. So let's get rid of that, rid of this, and have a think about the logic behind this one. So if we have this piece of information here, we've got that he did 15 kilometers in 40 minutes. So if we write up here 15 kilometers equals 40 minutes. There we go. Now we want this number here to be 60 minutes. And if we can get that to be 60 minutes, then that's going to be, obviously the amount of distance he does in that 60 minutes is going to be his speed. So if we have a look, what can we actually do to 40 minutes to break it down? Well, actually 40, I can turn back into 60. I can divide both of these by 2 to start with. And if we divide them both by 2, we get that he will have done 7.5 kilometers in 20 minutes, sorry. There we go, halving that, 20 minutes. I'm getting ahead of myself. There we go, 20 minutes. Now if we did 15 kilometers in that 40 minutes, 7.5 kilometers in 20 minutes, if we add these two together now, look, we get 60 minutes. And 15 plus 7.5 gives us 22.5. There we are, and that matches our speed that we did there with the calculator. So there's just another approach that you could take, obviously if this was a non-calculator question, but obviously if it is a calculator question, that's absolutely fine as well. You just need to remember that obviously you are using that time there in terms of hours and not accidentally put the minutes in, okay? So there we go, that is a bit of speed, distance, time, looking at journeys, looking at something a little bit more complicated here to finish, but that is the end of the video there. If it was useful, if it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.